we've been talking on the fundamentals of science, like what is matter, what is physicalism, and everything. Scientists use all the time. That's the theories that they have, and we've been talking about philosophy stuff, ontology, even metaphysical stuff. Is this the beginning of what the philosophers are bringing on the table when they talk with scientists?
Yeah, I think again, I can only speak to philosophy of physics and in particular philosophy of quantum physics, because that's where I live and breathe and have my being. And I've had some really lovely conversations and ongoing conversations with physicists in that regime. Yeah, I can't say, oh, I guess quantum cosmology is involved there too, like a great group of folks. I think people who are on these fringes of where we're at in terms of empirical testability understand even more profoundly the need to step back and ask questions about where are we headed next and why should we sort of invest in that avenue of research.
Hmm.
And so practically that means if you think the world is fundamentally quantized, like that our final theory is going to be a quantum theory, then you're going to pursue a different kind of physics if you're trying to find a theory of quantum gravity than you would otherwise. You will look at different kinds of possibilities for the way the world could be. You might even use different techniques for understanding general relativity because you don't think general relativity on that view is an ultimate theory because it's classical, right? Not quantized. So it's going to either get subsumed by some quantum theory or pop out of some, it will emerge or who knows. But you're going to primarily focus on quantizing classical theories. That is a totally different way of doing theoretical physics than if you're starting from general relativity, right? So that's just one example. Or in quantum cosmology, we don't have evidence about the early state of the universe. And so the kind of reasoning that it needs to be employed is given contemporary models or given analogous models like in hydrodynamics or something. Can we compare the way that a waterfall works to the way that the dynamics of a black hole look? That's a deeply philosophical question because these are entirely different systems, yet they have dynamical properties that look really interestingly analogous. But how good an analogy is depends on sort of your faith in how comparable these entities are, like black holes to what, right? So whether you even think a question is worth asking, like is it worth studying hydrodynamics in order to understand gravity or to understand black, depends on deeper commitments about what you think. What is a good kind of scientific reasoning? Science itself can't answer that question. Or what is fundamental reality? Is it quantized or is it a field of some kind or whatever? We haven't found an answer to that that's empirically testable yet. So those are just a few small ways that questions like why, and why is this research path a more interesting one? What does it mean to assume that space-time is fundamentally quantized versus not? What are some consequences of that make it a more or less appealing research avenue? So yeah, it's just getting in there and being the toddler and just saying, but why? But why? You published this thing, and what does it mean when you say that there's no causality at the quantum level? Or what does it mean when you say we can assume that this thing will behave like this model, etc.?
And do you make friends with scientists when you ask why, and stuff?
Well, sometimes. It's kind of easy. It's like you know who your friends are gonna be. They're the ones who like, oh, like this is why I got into science in the first place. Sort of attack these questions, but maybe with a slightly different toolkit. Maybe in their case, a literal toolkit, whereas for me, it's a analytic toolkit.
Hmm.
But yeah, some people are resistant. I was giving a talk to a bunch of physicists, and some of them came upward to me afterwards and said, yes, this is wonderful. I ask these questions all the time and so on. But then a few of them wanted to argue with me and say, why do we need a philosophy? I just read the data off my experiment. And that's where I sometimes lose my patience a little bit. Because even my freshmen in college can understand that even if I have if a plot of data points, to make meaningful connections between those data points requires interpolation. And that's a choice that that the world itself didn't give you. That is a choice about how to relate certain parameters that was not given, right?